In this video, we're going to look at example 10 and 11 on page 138. Here we are given a Venn diagram. Each circle represents an event. So this circle right here on the left side represents event A. The second circle represents event B, and the bottom one represents event C. So you can think of event A as, for example, rain or snow. B may be snow or hail or tornado, and C could be something else. So because you can see A and B, they both have snow, so they have a intersection right here. And so from the picture, those numbers given in the picture, 0.13 is only represents the probability of this left part on the left side of the intersection. So 0.13, suppose this little half part means the event, part of the event is rain. So the chance of rain would be 13%. And A also has this little section here, means the chance of snow is 7%. So together, it would be the probability. The entire circle of A represents the probability of either rain or snow. The rain is the left part, the snow is the right part. Okay, so similarly for B, B has is cut into three little sections. So this little part and this middle part and also this bottom part. So it has three numbers in there. And so first we understand what the picture means and what numbers represent. Just pay attention to this 0.13 does not represent the entire circle. It only represents the left part. Okay, so we want to look at part A. P of A, which means the probability of the event A. Using our previous example, the A, if A means either rain or snow, so it's kind of like asking you what's the chance of rain or snow for today. But of course, the problem when you do this problem, this A event A or B, C could be anything. That I'm just giving you an example to help you understand the problem. So what's the probability of event A? That means if you look at the picture, because the probability for the left part is 0.13, for the little right part, because these two sections, two parts, form the entire circle A, which represents the event A. So the probability of A will be adding the probability of these two little parts. And in our example, it would be the probability of either rain or snow would be the probability of the rain plus the probability of snow. So that's going to be 0.13 plus 0.07 equals 0.20. So the chance of rain or snow is 20%. And part B, P, we want to find the probability of B, C bar. We know C bar represents not the part not in C. If there's no symbol between these two letters, it means the intersection. So if we look at the picture, here I'm going to show you another picture so I can draw in here. So the symbol, the probability we're looking for is B, C bar. Well, it's kind of difficult for me to put a bar here. So let me do this. Here is a brush. So B, C bar. Okay, this means the intersection of B and C bar. So it's the common part of B and the outside of C. Okay, so that's the meaning of BC bar. If you look at the picture, notice that I emphasize the and. This is very important because we know we have another case union that is completely different. So and you want both. So you want the little section we're looking for here not only falls in B, but also falls outside of C. So let's first focus the inside of B because we want a section inside B. So look at the entire circle B. And inside B, we have three little sections. And so we have this little section here, and we have this big section here, and this little part here. So that's in three little parts of B. And now we see which parts also fall outside of C. So that, well, apparently this little section right here is inside B, which is not outside of is inside of C. So that's not outside of C. We want to look for, we want to find a part that falls outside of C. So that tells us that these two little parts, not only these two little sections not only fall inside of B, but also outside of C. So that satisfies the condition we want, BC bar. Okay, so by looking at the picture, it's very easy. The probability will be adding these two sections. The probability for this little part is 0.07 plus this little big part is 0.10. So we get 0.17 as in the answer right here, 0.17. Okay, the last part is the union. So you can see B, C are very different. B, you're looking for part not only in B, but also outside of C. C, this third question, we're looking for the probability of A or B. So you don't need a part that falls in both A and B. You just want a part falls either in A or B. So this symbol here, union, means sort of like English word or, either or. But if there's nothing, it's like both and. So if I go back to the picture, we look at the picture, which part is either in A or B. So we have B, wait a second, it's A or A union B. So A union B. In English sentence, A or B. So we're looking for sections either in A or B. First of all, if which part is in A, so we have to shade the entire area A, entire circle A, because this section falls in A. Or in B, well, then we have to shade entire circle B. And you notice that this little section is shaded twice, but it doesn't matter. This little section actually not only falls in A but also in B. That's fine. Well, it also satisfies either in A or B condition. So that's what we're looking for, these two circles together combined. But when we do probability, we don't consider this part twice. You will not add this number 0.07 twice because A union B does not repeat. Okay, so we will add all those numbers. The little is 0.13. The left side goes from left to right, 0.13 plus 0.07 plus 0.10 and plus 0.15. So these four little sections. So that's the solution given in the book. Adding those four numbers, 0.13, 0.07, 0.10, and 0.15. And this is the part, these two circles combined together is the section A or B. We can continue to look at the next example 11. We want to use symbols to represent both A and C. So both and it's B, C. And that means we're looking for the common part of B. So you are looking for a part not only in B but also in C. From the picture, we know this is the part not only in A but also in B. So, oh, I'm sorry, we're doing B and C, not only in B but also in C. So this is the part, 0.15, not only in B but also in C. And next part, second question, C occurs. So we write down the letter C. And no symbol for that. B does not occur. So does not occur means B bar. You can also write C B bar. That's also the same thing. So let's look at the probability. First, we found the area. Which part is C B bar? C B bar, similar to the question we did before, B C bar, but this time it's reversed. So we are looking for a part that falls out of B, outside of B, and inside of C. So first, let's focus on C. This is the circle C. So which part falls out of? In C, we have two little sections. We want something inside of C and also outside of B, of course. So it's the bottom part. The bottom part is outside of B, so it's the bottom, which is 0.28. And the last question, exactly one of the three events occurs. So we want just one of them, exactly one of them that occurs. So it means if A occurs, then we have A occurs, B does not occur, C does not occur. Or, so this symbol means or A does not occur, and B occurs, and C does not occur. Or A does not occur, B does not occur, and C occurs. So we have these three cases. And so let's look at the picture. Which part is, first we do A, B bar, C bar. Which part in the picture falls in A but falls outside of B and C? So we focus inside of A and outside of B and C. So that's the left part. Left part is not in B and not in C, but it's in A. So that's why we have 0.13 for that. The second one is inside B, outside A and C. So inside B, this is B, outside of A and C. So we gotta take A away and C away, cut A and C away. So that's this little middle section here, 0.10. And the last one is A bar, B bar, C. So it's outside A and outside B, but inside C. So focus the circle C. We want it to be inside of C, but you have to take B away. So because we want outside of B. So that's the bottom part, 0.28. So we add these three sections together because it's OR case. So either this or that or that. So we add these three. And because these three parts are three separate parts, they don't have share anything in common. So we can add these three probabilities together to get a 0.51, and that's the answer for exactly one of the three events occurs.